In this video, I am going to talk about the introduction to transformers. So in my preamble, we are going to define what a transformer is. So a transformer is an electrical device that is able to change or transform the voltage of the alternating current supply. It can lower or it can raise the voltage of the transformer, and also it can either lower or increase the current flowing in the transformer. For us to understand about this mechanism, let's look at the word mutual induction. So in mutual induction, we need to understand that a transformer is made up of the primary coil and the secondary coil. Both are coiled or attached to the soft iron core. So why are they attached to the soft iron core? It's because the soft iron core provides the chance or ability to create the electrical field, magnetic electrical field, between the primary and the secondary coil when the current is introduced. Now let's look at the two types of transformers. We have the step-up transformer and the step-down transformer. So how do you identify this is a step-down transformer and this is a step-up transformer? One of the physical things that can be easier for you to identify the step-down and the step-down and the step-up transformer is as follows. On the number of turns or number of coils. So when you see few coils connected to the AC supply, that means that side is known as the primary coil, and that type of a transformer is known as the step-up transformer. On the other hand, when you look at the secondary coil, it has more turns compared to the primary coil. So it is going again to amplify your answer to say this is a step-up transformer. When you look at the step-down transformer, you will discover that the primary coil has more turns or number of coils. And in this regard, it should also click into your mind that this is the step-down transformer. Now, on the other hand, when you look at the secondary coil, it is, or secondary coil, it has got number of turns, which few number of turns compared to the primary coil, and that should also amplify or qualify that this is a step-down transformer. In other languages, or in other words, let's look at the number of turns here. When you look at Zambia electric production, Zambia has got several sites that produce electricity, and one of them, which is normally known or which is famously known, is called Karibada. In Karibada and Cafe Gold, these are some of the electrical power plants. Now, one of the transformers that is connected immediately to the power plant is known as the step-up transformer. Why is the step-up transformer connected to the national grid immediately from the power plant? One, it is to avoid the wastage of or the loss of current through heat to the surrounding, as it covers the long distance. In this regard, the step-up transformer is connected to the national grid in order to increase the voltage and reduce the current, because there are many domestic or there are many consumers of electricity. So that is one thing. Now, how is this done? When you look at the number of coils, there are few primary coils, or there are few turns on the primary coil. Now, because the number of coils are few on the primary coil in the step-up transformer, this enables or this reduces the current and increases the voltage. In this regard, the number of turns determined in the primary coil determines the higher or the lower the voltage will be, as well as the higher and low the current will be. Now let me take you back to what I'm trying to say. So there are few number of coils or turns on the primary coil connected to the AC supply. This means that the few number of coils increases the voltage and reduces the current, while the secondary coil, which is connected to the galvanometer, has more number of coils, and because it has got more number of coils, it is responsible in increasing the current and reducing the voltage. In this way, we find that the step-up transformer is very useful. Let's look at the step-down transformer. So when you talk about the step-down transformer, you will discover that in the primary coil, there are more number of turns or coils as compared to the secondary coil. And in this regard, this increases the voltage and this reduces the voltage and increases the current. Why is it going to increase the current? Because mostly the step down transformer is mostly located in the substations. That's where you find the step down transformer. Why is it there? It is to lower the voltage so that it suits that which is used in our homes for home consumptions. For example, in Zambia, the voltage in houses, it is rated at 240 volts. So sometimes when since the current is reduced here in the step up transformer, just after the national or the power plant, and increases the voltage, meaning that the pylons that we see overhead, they have higher voltage and low current. Now, because they have higher voltage and low current, if that voltage is supplied to our homes, it might endanger our lives, and also the appliances might be damaged. Hence, the need to reduce this voltage to suit the electrical appliances that we use in our homes so that they cannot be damaged, and also to save our lives. Now, apart from this one, I want you to get this very well, that the step-down transformer is the one that is stationed in the substations, because a substation is closer to the consumers or to homes and areas or local areas that needs electricity. Hence, the reduction, these coils, there are main coils here in the primary coil in the step-down transformers. This reduces the voltage and increases the current. And in this case, this is the electricity that is found or that is consumed in our homes. Now, if you are watching this video for the first time and you need more videos of this nature, make sure you subscribe to Science Corner TV YouTube channel, and also make sure you follow our Facebook page, Science Corner TV.